Greetings and welcome to Dev Network's Developer Week webinar series. I'm Patrick Gallagher, and I'd like to welcome all of you to this week's featured webinar presented by Synopsys. Synopsys is a current sponsor of Dev Network events and provides solutions to help companies manage security and quality risks comprehensively across their organization and throughout the application lifecycle. So before we get started with speaker introductions, I'd like to remind all of our attendees that live chat and Q&A is available during the session, and that's on the right side of your viewer. You can raise your hand in chat. You can just put in chat. You can also put in questions in the Q&A section. All Q&A will be handled at the end of the webinar. In addition to that, the webinar will be recorded and will be made available within 24 to 48 hours to our viewers, as well as those who registered but couldn't make it today. And also, please make sure that you forward it on to your coworkers. They may have interest about this content as well. Finally, Synopsys will provide handouts which can be downloaded at the end of the session, and they can be found in the handouts section on the right-hand side of your viewer. So, joining us today, Utsav Sanghani, Senior Product Manager. Utsav is a Senior Product Manager at Synopsys and drives strategic cloud products to help the world's most innovative companies streamline and safeguard application security risks in their software. Prior to Synopsys, Utsav worked for Black Duck Software to lead the DevOps product practice for that organization. So, without further delay, please give your undivided attention to Utsav. Utsav?
Thanks, Patrick. Hi, everyone. Thanks for having me. Today, I wanted to, as Patrick introduced the topic, wanted to talk to you about shifting left and what that really means in the context of application security and how we try to enable and empower the developer. But before we get there, let me spend a couple of minutes just talking about who I am. So my name is Utsav Sanghani, and Utsav translated is a Sanskrit word for festival. And my name means festival. I've been with Synopsys and Black Duck a combination of 5+ years now. Black Duck was acquired by Synopsys a couple of years ago, and that's how I joined the Synopsys organization. I am an engineer by qualification, but I choose to be a product manager. I love technology, and I've been doing this a while. I spent the last 7+ years in the application security space, primarily focusing on static analysis and software composition analysis. And I am based out of the East Coast in Burlington, Massachusetts, a Red Sox fan. So that's a little bit about me. And I want to get started as to what we're talking about today and why we're meeting today. So let's first sort of zoom out and understand the overall application security landscape and trying to understand what are the different nuances which sort of influence the topic of shifting left. So if I look at modern software development today, right, there's a lot of code, there's a lot of complexity. When I say complexity, it depends on the languages, the platforms, the frameworks that you end up choosing for your code base, what component of that is actually built by your development teams, what part of that is licensed from a third party, what component of that is actually getting introduced through open source. So there's a lot of complexity and too many moving pieces that go with actual application development. And then we always have this constant pressure, and I think everybody on this call can relate to this, is there's always the need for more velocity. The go-to-market pressures are immense, and developers are always sort of forced to try and be a little more agile, improve their overall throughput, and do that in the context of a CI/CD process to accelerate velocity. And then obviously with so many different surface areas to cover, the overall threat and risk increases, and so you're now susceptible to additional cybersecurity attacks, and that's another area that you need to be cognizant about and figure out how you can avoid that. So for today's discussion, I'm going to focus on the two middle blocks highlighted in red, the complexity aspect of it and the dev velocity aspect of it, and how we're trying to solve these problems with a productized implementation that I'll, if time permits, be able to demonstrate at the end of this session. So let's dive into this. So let's look at simplifying things, right? How are apps really built? So we have a bunch of proprietary code that is written by your development teams that basically is designed to sort of figure out the nuances of your application, and that's built on top of open source libraries. And so the questions typically we get asked is, how do I manage what type of proprietary code is coming in? What are the security and quality issues that go with it? If I'm using open source code, is the open source code in compliance with my security policies? Is it potentially introducing any legal and licensing challenges in my code base? So those are questions that typically come up. And as you can see from the nature of the questions, no two questions are alike. Depending on the nature of the code base, it's very, very different. Then if we go further upstream in the application development sort of life cycle, involving the front end web UI, and you want to be able to understand, how issues and security vulnerabilities are coming in through a bunch of APIs that your UI is using, or maybe just backend APIs that are getting called, right? So how do I ensure that the payload that these APIs are returning, is it in compliance? And what data is it returning, right? There's no checks and balances in place to verify all of that. And so this is one of the biggest reasons why we at Synopsys constantly talk about not having one uniform solution that can address all of these problems. And today in our portfolio, which we've built over the course of the past decade, we've very categorically identified best of breed solutions that can help you solve these problems at different stages in your development process. So for example, with proprietary code and handling the security and quality issues that go with proprietary code, a solution like Coverity or static analysis is well suited to help in that area. With respect to open source code and open source management, you typically look at software composition analysis or open source risk analysis. Software composition analysis, I'm not sure how familiar this group is with that terminology, but think of it like a nutritional chart for your application that lets you know what percentage of your code base is proprietary, what percentage is open source, and then identify all the security issues with your open source code. So that's SCA. Then we have interactive analysis and dynamic analysis with our Seeker and Tinfoil product line. And then we have Defense6, which basically will help work at the service interface level, fuzzing for specific protocols, the Bluetooth protocol, if you are in the business of creating devices that are communicating over the Bluetooth network, for example. So all of these products and the nuances that they capture force these silos and require the existence of these components and technologies to be separate. But we've started seeing the emergence of this new macro trend where as software development becomes more a democratic function, where every persona in the SDLC has some set of pre-assigned responsibility that they are asked to work on, be it with respect to development, automation in terms of your CI processes, your ops processes, then production deployment. Everybody is sort of working together in a fluid manner to sort of bring it all together. And with the emergence of DevOps has come this need to break these silos that basically exist today in best of breed solutions in the market. And this is where Synopsys' most recent announcement with the Polaris platform really brings it all together and provides you with the contextual relevance that is most applicable for your application. So one stat in this regard that I really want to bring up, and I use this quite often because it's really true in how I've seen the market evolve and how I've seen our customers embrace this. So back in 2017, almost 3 years ago, we had Gartner make a prediction that DevOps practices, both from a process standpoint and as a cultural standpoint, will gain rapid mainstream adoption, and it's going to be embedded in 80% of all rapid development teams. And I don't know how many of you guys agree, or if your organizations have started going down that path, but the fact that this acceleration of DevOps practices has further picked up steam with the unfortunate situation we're in right now with COVID-19, where all of us are working from home, we're remote, we're accessing systems remotely, and there is this there is this constant pressure of, obviously not being in person in the office together creates some problems. But some of these practices ingrained in DevOps philosophies really help us remove some of those requirements and make it a much more fluid process. So we've seen a lot of accelerated adoption of DevOps practices across organizations. I mean, typically we would see 4 or 5 teams do this within a big, say, a commercial bank or within a big ISV. We would see this happen maybe 3 or 4 teams a year, and that's sort of gone up to almost 6 or 7 teams in the past 6 months, because everybody's working from home and that's the need of the hour. So this trend is continuing, and that's resulting in customers sort of getting higher throughput speeds, lowering their overall costs, trying to reduce friction, and obviously continuously supplying feedback so that it provides that complete loop of whatever problems are getting identified, be it from a security standpoint, quality standpoint, etc. So with that in mind, we brought to market a capability that could really help accelerate this adoption, and we saw the market leaning very heavily in that favor. So I spoke about the Polaris platform, which is sort of the overarching idea, but a specific portion of that is what we call as CodeSite, which is exclusively targeted for the developer persona, and developers and dev managers looking at basically incorporating the feedback that has come in through their automated processes and work towards delivering software that is of high quality, secure, and at the same time doesn't really derail their throughput velocity. And so we categorically went back to the drawing board, trying to identify how these technologies can work together in the context of, say, an IDE plugin, for example. So we have static analysis and SCA. Now, for a developer, they need to stay in compliance with the security solution. They don't really care if it's static or SCA. They just need to understand what works and makes most sense for their code base and how they can apply it. So we've sort of incorporated these two technologies together, which is, by the way, the first time ever that has been possible in this industry. And Synopsys has been leading the charge in that regard. Today, you may have used or are currently using plugins either for static analysis or SCA, but you're using it in silos, and it really gives you only partial coverage over your code base, depending on how your application is built. So if you're just using something for static and 80% of your code base is open source, you're not getting coverage for that 80%. So those are nuances that people tend to forget. And I think what we want to do today is bring that up and tell you why we've combined these technologies together. Another additional point I want to bring up is how we're trying to promote developer productivity. We're not trying to position this as a security solution, but a solution that helps developers improve their productivity. So if there is a malicious piece of software that is in their code, it doesn't get detected further downstream and come back to them so that they have to fix it with additional pressure constraints on them to fix it. So it really is cheaper. It's more cost effective. It's more efficient. And it even helps security guys nip it in the bud at the development level rather than have that propagate downstream and then get figured out later on in the process and then pushed back to development, which can be costly. So that's the second point. We support native integrations with all major tier 1 IDEs. I mean, Visual Studio, VS Code, Eclipse, IntelliJ, and the IntelliJ family of IDEs. We provide you with remediation guidance that gives you the ability to automatically fix certain vulnerabilities that are eligible. So certain open source vulnerabilities that can be fixed by just upgrading the component, we can give you that information and allow you to hit that magic button so you can actually fix it. And I'll if time permits, I'll show that to you today at the tail end of this session. Lastly, if there is no automatic fix available, but there is a best fix location that we can help you pinpoint and provide you with actionable remediation guidance, excuse me, we go as far as to give you line-by-line information as to why a particular security or quality issue is coming up and what's the best way to solve that. So these are some of the highlights that I wanted to bring up as to how we've tried to solve this problem in a productized fashion and bring together technologies that historically have always lived separately. And so another data point that really drove this thinking was around a study that Forrester did, another major independent analyst who looks at this market. And Forrester actually, and this is a study that happened late last year, they reviewed, I think, 600 plus organizations with 1,000 employee plus members in this space, and they found an overwhelming 41% of them who want to implement static analysis, as an example, in their development process. Today, most of them have static analysis either in testing or production, which is further right in the SDLC and too expensive for them to be able to remediate, stay secure, and yet not slow down their development velocity. And so I think this is a good sort of segue into a poll that we wanted to run. And Emily, do you want to maybe, there we go. So how many of you are interested in adding software composition analysis and static analysis in your developer pipeline? I'll give you a few minutes to do that poll, and then we can review the results. Okay, I see results coming in. Let's give it another minute. See, the numbers are staying static, so I'm assuming everyone's had a chance. Oh, they changed again. 30 seconds. Going once. Okay, I think this is so not surprised. I have close to 81% of the audience who wants to move their software composition analysis and static analysis functions into the developer pipeline, and we have 19% of the participants who don't feel this is the right thing for them to do. Awesome. Thanks for the feedback, guys. And this, I think, lines up really well with what we're noticing as well, where depending on the constraints and the industry you work in, movie shifting left for the most part makes a ton of sense to make it more productive for you. So thank you for sharing your highlights. Continuing on the topic of some of the macro trends that I really wanted to bring your attention to is today, if I now zoom out of the whole static space and look at software composition analysis, I wanted to share certain findings that we've done in our most recent OSR report. The OSR report stands for Open Source Security and Risk Analysis. So we've analyzed more than 120,000 open source projects. And in these open source projects, we've identified 16,000 open source vulnerabilities. And these are live vulnerabilities. And these are disclosed every single year, as new versions come out, and as security researchers try and understand if there's a security vulnerability attached to a piece of code, piece of software, they want to be able to responsibly publish that. And so this number keeps growing. And what I want to do is not initiate a sense of panic, because these are really overwhelming numbers, but to bring your attention to the fact that these are open source packages. These are your popular Apache, Tomcat, these are your Log4js that are being used today. And these are really helping your teams accelerate their velocity. But when they do that, the underlying security concerns get ignored. And those underlying security concerns will continue to stay, because the developer, when they use these open source components, if they do have any potential security vulnerabilities, they're not going to try and fix it, because this is an open source project. They'll try and upgrade or change a component so they can be in compliance. But how do you know you're staying in compliance? Which is one of the reasons why we have technologies like SCA that really helps developers understand when they're trying to choose an open source component. Let's say I'm in my POM file, I have a Java project that's built on Maven, and I want to be able to introduce a dependency that I explicitly declare in my POM file. How do I know I'm making the right choice? I may just choose a version that's maybe 18 months old. How do I know that? And with that comes in a bunch of security vulnerabilities. So these are numbers that I wanted to make them an eye-opener for everyone that these numbers will keep growing, and all we need to do is responsibly navigate through these waters and make sure we're choosing the right open source component. And then if you look at CVEs, and people familiar with the common vulnerability enumerator metric and the US Department of Cybersecurity that helps manage this, as part of the National Vulnerability Database, we see on an average of 40 exploits that come out every single day. And these are stats from very recently, 2019, when we analyzed all the exploits that came out. So this is quite an overwhelming number, which really brings our attention to, okay, we should probably be serious about SCA. Additionally, we saw a lot of the code bases, a vast majority of them, 60% plus, who really had active live vulnerabilities. This is production code, by the way. This is production code that our customers were using, our customers were scanning, and we found more than 60% of them having vulnerable code. And 40% of those vulnerabilities were high-risk vulnerabilities. These vulnerabilities were the ones that can be easily exploited by a malicious hacker. And we've seen some of these exploits in the past few years. And so these are stats that we wanted to put together and really understand why this interest in the shift in SCA is picking up steam, and these silos between static and SCA seem to be dissolving. And then looking at sort of the average data, and we've identified from our internal audits where we're scanning customers' code bases, we've seen most of these projects on an average have vulnerabilities that are older than 8+ years. So 6 to 8 years is a pretty strong average that we've seen, and this is a very shocking stat that really brings our attention to the problems that come with open source, and the rewards are just overshadowing some of that. And so it's important to understand that, acknowledge that, and work through that to make sure we're staying in compliance. And then obviously, the goal with moving these technologies together, again, is to make sure you have higher speed. Your developers are not wasting time, triggering a scan and going and grabbing a cup of coffee, because that's highly inefficient. It's the 1980s model, which really doesn't fly today with the go-to-market pressures we have. We wanted to reduce the total cost of ownership for you, because every piece of malicious code that you propagate into your process, into your life cycle, becomes all the more expensive for you, because you now have to tackle it at different stage gates that you have set up, and really just creating a bunch of alarms and escalations when you could just nip it in the bud and have developers sort of handle this at the development level and consciously figure out what components to pull in and how to write high quality software faster. This obviously in turn reduces friction and provides for continuous feedback to these developers. And so that remains our go-to sort of objective by combining these two technologies. So that's pretty much it. We talked about the problem. We talked about how some of these macro trends are really influencing the confluence of technologies to come together, and doing that in such a way that it's not expensive, it's very effective for organizations, and sort of shifting the processes further left within the SDLC by having developers organically embrace this. And so how is this thing going to work, right? So let's do a live demo, and I hope the demo gods are with me, and take a look at the magic. So I'm going to share my screen here. Bear with me. And I am going to open up my IDE here. So what I have in front of me is the CodeSite IDE plugin, and this is the specific IDE capabilities I walked through today. So just like your developer would download a plugin from the marketplace, these plugins, these Synopsys CodeSite plugins, are available on the marketplace. Then they can search for it from within the marketplace. So you search for CodeSite and it will come up. For this demo, I already have this installed and configured, and I hit OK. It restarts the IDE. And then once you are done, it's going to prompt you and it's going to show you a screen similar to this one here, which is where it's going to tell you Oops. There we go. So my IDE crashed there. So it's going to tell me the different components really needed to do the scan and how I can get this operationalized. So I downloaded the first block, which is the plugin from the marketplace. I then connect this plugin to my Synopsys server. This can be the Black Duck SCA server. This can be the Coverity static analysis server. And all I'm really asking the user to do is authenticate their IDE plugin with the server. So typically, depending on how you have set up, if you're a Synopsys customer, you would have a central server that's either on premise, that's behind your firewall, or as part of our cloud deployment on our public cloud network. So works with either of those situations. And so you would just put in your credentials, put in your server URL, and connect. Once you are done with that, the bare minimum configuration, all CodeSite really requires you to do is add, open, or edit an existing file, and it's going to initiate automatic scans. So in this list here, I'm looking at all scan files, which is basically a bunch of Java files that I have here, and the pom.xml for all of my open source packages that I have defined, that I have explicitly defined here. So I have this Spring Framework Pet Clinic application, pretty standard. You can find it on GitHub. It's an open source application. And I have a bunch of open source components that I have pulled in here. So I have Spring Framework that I'm using 5.1.15. I'm using a bunch of other dependencies here as well. You can see I'm using the Jetty Maven plugin, the compiler plugin versions. So it's a pretty standard POM file for this application. And what the SCA component is going to do is going to help me identify these direct dependencies that have come in based on my declaration, and also the transitive dependencies that these direct dependencies are pulling in. And again, the only way to really trigger something like this is basically introducing a new file or making edits to a file, and the plugin will automatically scan the file in the background and give you results in a matter of seconds. And once those results come up, it's going to give you, so let's look at a sample static analysis result. So I have a cross-site request forgery, and I'm going to go to this file. So it's going to open that up for me. It's right here, line number 64. And it's telling me that this is initiating a cross-site request forgery. And so if I am a developer, I frankly may have heard about this, but given that none of the top 40 computer science programs in the US and globally have any mandatory coursework on cybersecurity, I really don't know what cross-site request forgery really is and how I can figure out the nuances of it so I can fix it. What we're trying to do is we're helping developers understand what this problem is, tell them where in the code this is coming in from. So it's coming in line number 64. We have inline annotations and icons letting you know. We even tell you how your code is getting executed, so you can see what lines are actually causing that issue to happen on line 64. And we also give you some of the category metadata, so you know it's a high impact security issue. It's related to the CWE 352, and I can open this up. It's going to open up in my browser. It's going to tell me how do I resolve this. So you create a crypto token to authenticate, and this way you're able to safeguard some of this. And then there's the whole learning aspect that we also pull in. So we provide you with links to our coursework on effective security training on, attack and defense, for example, the OWASP top 10 issues, for example, how do you prevent cross-site request forgery. So there's the angle of identifying the issues, fixing those issues, and then there's the education angle, really helping developers understand, acknowledge, and empower them so they can avoid such issues in the future. And that's basically the goal of how CodeSite is trying to solve this problem, yet keep it friendly and help developers organically generate interest for this. Because if you position this as a security solution that's highly inflexible, there's a lot of overhead to deal with, it's never going to organically generate interest. And so we're trying to position this as a way to help developers reduce the overhead that they have to reduce, that they currently incur with security, and still comply with all the security policies. So this is an example of a static analysis issue. In parallel, I have, let's say, an SCA issue here. So I'm using, let's use the Jackson parser, the Jackson data bind component. So I'm using Jackson data bind 297 in my POM file, and it's telling me that it has 35 issues. So from when I say 35 issues, it has 35 live vulnerabilities, open source vulnerabilities. And you might see these labels called BDSA, and you might see some labels listed as CVE. The CVE vulnerabilities are coming in from the National Vulnerability Database, which is maintained by the US cybersecurity arm. And this is a public forum that basically educates people around security exploits that are out there that are affecting open source components. But in addition to the CVE information, in our experience handling open source vulnerabilities, we've noticed that oftentimes the time it takes for an exploit to actually hit a component and the time it takes for it to really get published on the National Vulnerability Database and then be consumed by security vendors like Synopsys, the lag time is 6 weeks. So we have a research facility internally out of our Belfast office that exclusively focuses on leveraging popular threat modeling techniques to basically understand if there is a vulnerability lurking around in your code and letting you know if that vulnerability has any potential impact for your code base, for your application, and how you can solve it. So those security feeds are categorized under this BDSA label, which stands for Black Duck Security Advisory. And you can open this, you can understand the description of this issue. It gives you links back to the central system that really has all the information if you want to do a deep dive. It also gives you a corresponding CVE link if available. So in some situations, the National Vulnerability Database does have an exploit listed, but does not have a fix mentioned there. So we make sure that we partner with them, we provide a fix, and we share that information, and we exclusively share that information with our customers so they get a lead time with respect to solving that problem and really don't have to worry about any potential exploits affecting their applications and their end customers. And so these are the security vulnerabilities that we highlight here. Now, for me as a developer, I see this has 35 issues. How do I fix it? So I have this option to fix it, and it'll tell me once I click on it that I need to go to this component, Jackson data bind 211.1. So I'm going to go to my POM. I'm going to search for Jackson data bind.1. Let's say this is not the one. I've got a bunch of Jackson components here. I'm going to search for the right one. All right, I find it, group artifact dependency. So I found the dependency. It's using version 297 that got resolved at build time. So I need to upgrade that to 211.1. And when I upgrade that to 211.1, I can hit rescan, and it triggers a rescan, if you can see at the bottom. In a matter of seconds, that issue will disappear once I fix this. So in addition to, so this one doesn't qualify for automatic scans because it's an unknown package manager that it's finding, and it's not able to identify the version because it's not explicitly listed here. So you have to manually change it. In some situations, we have automatic fixes. So you just hit the magic button and it's gonna fix the underlying problem, and voila, it disappears. Again, all of this happens in a matter of seconds, as you saw. And that's pretty much it. I can change the scope. So I can look at just the set of files that I'm interested in. In the pet controller Java file, I have just 3 issues. But if I expand my horizon to look at all scan files, which is all of these half a dozen files that I have open, I can see additional issues coming in. And I have timestamps. So this really lets me know if this is something historically existing in the code base, or have I introduced something with my particular branch level changes. And that's pretty much it. CodeSite is available to all of our Coverity and Black Duck customers. And if you haven't really had the chance to check it out yet, I encourage you to check out our support page and download the plugin and take it for a test drive. With that, I am going to turn it back to Patrick and Emily. Patrick?
Yeah, great. Utsav, thank you very much for a great presentation, interject presentation. It was really awesome. But before we get to the questions, we do have 4 questions in the Q&A section. So Utsav, if you want to go to Q&A and new, I just want to remind everybody that there are handouts available in the handout tab on the right-hand side of your viewer. So make sure you go there and you download the handouts that Synopsys has left for you. Some great information there. Okay, we're going to get to the questions. We've got 4 questions right now, just as for everybody else. We do have a few minutes, so if anybody wanted to add additional questions, please feel free to do that. And again, do that in the Q&A section, not in the chat now, but if you could do it in the Q&A so that we can see it readily available. Utsav, you want to hit the first one? Maybe start with Paul's at the bottom. Start that as the first one. Paul Starrett.
Sure. Thanks, Paul, for your question. So Paul's question is, do you support PyCharm and VS Code IDEs? Yes, we do. So PyCharm is part of the JetBrains IntelliJ family supporting Python code, and that is currently supported. So is VS Code IDE. VS Code, by the way, as some of you know, is pretty popular given its dynamic nature with supporting a lot of languages and the fact that it's so lightweight. So yes, we do have a plugin for that as well. So thanks for your question, Paul. Balaji had a question, and his question is, will the scan report open source libraries, vulnerabilities for open source libraries like Apache Commons, Spring Jars, and Node.js libraries? Balaji, absolutely. The SCA component that you see as part of CodeSite is designed to identify all these open source dependencies, both declared and transitive, and covers all of the ones that you mentioned, and spans multiple different package managers. So Node.js for JavaScript, Spring Boot, Apache Commons, these are all Java dependencies. So yes, it covers all of them. Quentin had a question, is there a trial license for Coverity? Yes, there is a trial license for Coverity. I recommend you go to our website, www.synopsys.com/Coverity, and that will help you initiate a process to get a trial license. We also support PowerShell in terms of scanning for, assuming you have a lot of scripting in the Microsoft context. So yes, we also support that, Quentin. Hopefully that helped answer your question. Let's see. I have another question here that says, with CodeSite, can managers see how many vulnerabilities that developers have found fixed in their IDEs? Absolutely. So we have a capability called Desktop Metrics Service that basically aggregates the data that your developers are generating as part of their IDE use, and it bubbles it up at an application level. So you know that, okay, for application ABC, you have developers scanning this frequently. These are the number of issues getting identified. These are the number of issues getting fixed. And this will essentially help you understand more at the management level if there's lack of education, if there's lack of understanding or skill set that really needs to be improved. If for whatever reason you see time, on a timeline, on a time scale, you see the number of issues growing higher and the rate of remediation is actually dropping. So those are insights that we bubble up and show you in a graphical manner in the central server. Ashish has a question, going to the next one here. Will this capability do deep dependency scanning? Ashish, yes. Assuming by deep dependency scanning, you mean having a declared dependency and the transitives that it may call and sort of the whole tree structure that goes with it. Yes, the Synopsys SCA capabilities are designed to do that, and so they can traverse through that structure and give you sort of a relationship chart that we can then expose in the IDE that tells you how declared dependencies and the transitive dependencies relate to each other and in what context are they present in your application. Another question that has come up is, how can I ensure that CodeSite won't slow me down in my development? Great question. So we've all seen in our professional life IDE plugins really coming in to help solve security use cases. But the exception with CodeSite is that we've kept the focus on the developer and not on security. Securities are sort of our core focus, but keeping this specific to development requirements and developer needs really helps with ensuring that it's performant. It really doesn't bring down their system. It really doesn't disrupt their processes while trying to align with whatever security requirements are being asked for at the security management level with respect to static analysis, SCA, how AppSec overall needs to be handled. So we've made sure that we deliberately add a lot of focus and attention to that aspect. I think that's the last of the questions. Did I miss any one of them?
I think there's two more. There's one. Another question with CodeSite: can managers see how many vulnerabilities their developers have found fixed in their IDEs?
I actually answered that, Patrick. So I think we can.
Oh, I'm sorry. I apologize. Sorry.
I think the other one is
yeah. Does IDE-based testing have significant limitations?
No. So what we've tried to do is we've emulated the same analysis engine capability that you would see on your central server as part of your CI capabilities, and we've retrofitted that in the context of your IDE environment, so it remains performant, fast, and does not really require you as the user to make a compromise just because you're running it in a different environment. So we made sure we keep that balance of precision and speed.
Got it. And it looks like Paul Starrett has a question on cost.
So Paul, I'm a product manager. I wouldn't be the best person to talk about the costing aspect of it. What I would recommend is if you could share your details, I can have somebody on our team chat with you and discuss next steps.
Terrific. And Paul, if you could do that, just put it into the chat area for public chat. Put in your information, your email address, and a phone number, and then somebody will contact you. And actually, Utsav, is there an email? We're actually putting your email address, I believe. We're going to get it into the chat as well. But while we're getting that into the chat, can you let everybody know, all the attendees know what your email address is so they can contact you if they have additional questions?
Sure. So my email address is, and I'll just write that up in the chat window. It's my first name, Utsav, S, my last name initial @synopsys.com. If you have further questions or you just want to discuss, feel free to send me a note. Happy to discuss.
So it's utsav.s @synopsys.com.
@synopsys.com.
Okay, so we just put in there. It's just a little bit off. So it's Utsav utsav.s @synopsys.com. So if anybody had, oh, sorry, go ahead.
It's utsav s @synopsys, no dot.
Oh, okay, got it. And so if anybody has any additional questions, also there is information on the handouts, so you can get some information there, and there is some contact information on the handouts as well. And then Paul is asking, can he put it in a private area? Yes, Paul, you can put it into the private chat, and you can chat directly to myself or Utsav. So you can do that. We will leave the webinar on here for a couple of minutes, so if you wanted to be able to do that. And it looks like doesn't look like we have any other questions. I wanted to say thank you to Synopsys and Utsav for your sponsorship of today's online learning session, and also remind all of our attendees that this recording will be made available in 24 to 48 hours for review for those who are attending today, as well as those who could not make it. And then you can also forward on to your coworkers if they have interest as well. This recording will be added to our Dev Network and Developer Week content archive, and that's found at devnetwork.com. A final note, again, handouts available in the handout section. And that's about it. If anybody else has any additional questions, please feel free to put those questions in the chat, and we look forward to seeing you at our next webinar. Thanks a lot, guys. Have a great day. Thank you to Synopsys.
Thank you. Stay safe, everyone.